Now we move on to our hydrocarbon derivatives. So these are called hydrocarbon derivatives because they're going to contain additional atoms over just C and H. Okay, they still have to have the C and H, but now they are going to have some additional stuff in them. So first kind of hydrocarbon derivative we are going to talk about is an alcohol. So an alcohol is going to be a hydrocarbon that contains an OH or hydroxyl functional group. So don't confuse these with hydroxide and bases. Main reason for that is all organic molecules are molecular compounds. They are not ionic compounds. So although that OH kind of looks like hydroxide, they're not going to lose the OH and make a basic solution, okay? So we call it a hydroxyl functional group. So anytime you see that OH, that's going to indicate to you that you have an alcohol. So when it comes to naming and drawing those alcohols, again, a lot of our steps are going to be exactly the same. Okay, step one, find your root. So you're looking for where is the longest carbon chain. The thing is now that that longest carbon chain has to have that hydroxyl group attached to one of the carbons in the main chain, okay? So the hydroxyl, although it's not actually in the main chain, has to be attached to a carbon in the main chain. It can't be attached to a carbon that's in a side chain, mainly because we don't talk about how to name alcohols that are in side chains. So we're going to make sure that it's always on that main chain, okay? So the root itself will pick the appropriate name. When you get to the suffix, so the suffix is always going to end with an dash number dash all, okay? Why we need a number? We need to know where to put the alcohol. If we don't have a number, we don't know where to put the alcohol. Why it's ending with an is because most of the time alcohols are actually alkanes, right? So if you think about alkanes, they would end with ane. It's a little bit weird of a rule, but what happens is that E, right, if you think about it, normally it would be ane, right? A-N-E, not just an. So where does the E go? Well, the E is kind of associated with a really old naming rule, which, although it doesn't apply anymore, they've kind of kept the E because of it. So if you start looking at stuff online, you'll notice that sometimes the number is here between the an and the all, but sometimes it's way earlier in the name. And that's just the way it used to be. But they've since changed it and put it in between. So why that whole E thing? So why we get rid of the E? Just sounds weird to have aniol, right? If you think of like methanol, it's not methaneol, it's just methanol. They didn't really want the double vowel, so they drop the E. There are some situations where the E gets to stay, right? If you look down here, we have something with two hydroxyl groups, right? So just like with all our other side chains and stuff, if we have two of something, we're going to call it a di, right? So if I have two alcohols, I'm going to call it diol. If I have three, I'm going to call it a triol. So in the case of calling it a diol or a triol, the E gets to stay. And the reason the E gets to stay is we don't wind up with that double vowel issue, right? Because it wouldn't be aniol, it would be anediol or antriol, okay? So weird rule. But if it's just one alcohol, you lose the E, no E. There's a diol or a triol, the E gets to stay, and you're going to include that in the name, okay? So, prefix. Just name a number of any side chains that you have on the main chain. So, somewhat similar to our aromatics, there is a second way to name alcohols. So when I would use this second way of naming an alcohol is if something else has to go in the suffix. So for example, if I have benzene, which has two alcohols on it, let's say, it's not going to change the ending. Instead, what it's going to do is I have to put it somewhere else. And you'll see when we do some of these other functional groups, that are coming up, that there are some things that have to go in the suffix. So basically what it comes down to is if your molecule is anything other than an alkane, the alcohol is actually going to go in the prefix. It's not going to go in the suffix. If it's an alkane, which most of the time is what you're going to have, it's going to go in the suffix as an -al. But if it's not an alkane, right? So if something else must go in the suffix, this is going to happen when it's not an alkane, you're going to name the alcohol in the prefix as hydroxy. Okay, it is somewhat confusing because it's called a hydroxyl group, but when we put it in the prefix, it's just hydroxy. There's no L at the end of it. And then we're going to use a number to indicate its location. Okay, if this is what we're doing and it's going into the prefix, if there's other side chains in the prefix, it's going to go in alphabetical order, so you're going to fit it in wherever it needs to go. Okay. The last difference comes down to your order of priority. Okay, so our order of priority, again, this is only in the case of a tie or if it's cyclic. Your alcohol or your hydroxyl is first. Then it's your triple bond. Then it's your double bond. And at the end, it's alphabetical side chains. Okay, so let's look at a couple examples. Okay, so we have two examples here, so let's start with the one on the left. So same thing as always, I want to start by figuring out where my longest chain is. So again, when we get these line diagrams, which we're definitely going to see, we have to make sure that we can identify where our carbons are. So there's one here, right, because there's a bend in the line. There's another one here, because there's a bend in the line. And there's another one here, because again, there's a bend in the line. Okay, there's none here, because that's where my OH group is. And same with over here, and same with down here. So there's only 3 carbons in this one, okay? So numbering wise, it doesn't matter whether we go this way or we go the other way. There's going to be that hydroxyl group at all of them, okay? So I recognize this is an alcohol, and I recognize it's an alcohol because it has the OH. Next thing I want to recognize is it an alkane or is it not an alkane? In this case, it is an alkane. And why I want to do that is I want to be able to know where I need to put that alcohol. Does it go in the prefix as hydroxy, or does it go in the suffix as an -al? So because this is an alkane, it gets to go in the suffix as an -al, okay? So my root, I have 1, 2, 3 carbons. So it's going to be a prop, right? We said we would put that ane or just an, okay? How we're going to decide whether the E gets to stay or the E gets to go is it just an -al or is it a diol or a triol? Well, we have 1, 2, 3. So it's a triol, which means my E gets to stay. Okay, only if it was an -al would that E go away. Okay, then we have our dash, 1, 2, 3. We need to indicate all those numbers. We can't just not put them. Sometimes people are like, well, if I don't put them, you would know to put 1 at each spot. But if you think about it, we didn't draw them in, but there's 2 hydrogens here, and there's 1 here, and there's 2 over here, right? So technically, if it was a triol, I could hypothetically have all 3 of them on this first carbon, and it wouldn't look like this, which is why we need those numbers. Then dash triol, okay? So now we look at this one. So I'm going to recognize 2 things. I'm going to recognize it's an alcohol because I have these OH groups. So one thing to notice is notice how this OH over here is actually written as HO, not as OH. There's a reason that's done. And the reason is that this oxygen is the one that needs to be bound to multiple things, right? If I drew it instead of that way and I did it like this, don't do this because obviously I'm going to erase it, but let's say I did it like that instead of like this. That would imply that the O was attached to the H, but that H is also attached to that carbon. And if you remember, H can only attach to one thing. It can't be attached to 2, and O really should have 2 things attached to it, okay? Which is why we don't write it like that. we write it instead like this, always making sure that is the O that is attached to that thing, okay? So recognize it's an alcohol because I have OH. Next thing I'm going to recognize is that this is aromatic, and it's aromatic because right here we have benzene. So although it's an alcohol, just like the last example is, this isn't going to be a triol, and that's because this is benzene, right? The only way it gets to go as a triol at the end of the name is if it's an alkane, which this is not, okay? So before I start naming, I guess we got a number. Doesn't matter which one of these we choose to start as one, they all have the same order of priority, so you can pick wherever you want. Also doesn't matter if you go clockwise or counterclockwise, it's also still going to work out to give you the exact same thing. Okay, so when we do that, naming wise, we have a 1, 3, 6, no, not a 6, a 5, right? Because this is 1, this is 3, this is 5. Then we're going to have trihydroxy. Okay, tri because there's 3 of them, and hydroxy because 1, 2, 3. And then benzene. So this is a 1, 3, 5 trihydroxybenzene. So properties of alcohols. These are a little bit different than all the other ones we've talked about so far, and that's because we now have this alcohol group. Okay, this alcohol group is going to make our molecule polar. So that means when we think about the intermolecular forces that we have in these, we still have LDFs like we did with all the others we've looked at, but now we're polar. So that means we also have those dipole-dipole attractive forces. And we also have those hydrogen bonds because we have H directly attached to an O. So we have more intermolecular forces at work. That means we're going to see some different trends for alcohols than we did for the others. So because we have that hydroxyl group, we're going to find that small alcohols are going to be polar. That means they are going to be soluble in water. As your chain becomes bigger though, that alcohol only affects a little bit of the molecule, and the non-polar property of the rest of the thing is actually going to make it non-polar, okay? So little ones are polar and will dissolve in water. Big ones are not polar and are either going to be soluble in hexane if they're aliphatic, or they're going to be soluble in benzene if they're aromatic, okay? So another property, alcohols are toxic to some extent, right? That is why many alcohols are not safe for human consumption, okay? So if we think about our melting point and boiling point trends, we've already figured out where alkynes, alkanes, and alkenes were. You are going to find, though, the alcohols look pretty different. The reason my alcohols look pretty different is intermolecular forces are a little bit different, right? We're saying that little ones have LDF, dipole-dipole, and hydrogen bonds. But then we also said that as they got bigger, that dipole-dipole would have less of an effect. So what we actually find is they don't do this straight line like alkynes, anes, and enes do. They're going to follow more of a check mark. Okay, and the reason they follow that check mark pattern is the little ones over here have LDF, dipole-dipole, and hydrogen bonds. As we increase the number of carbon atoms, our LDFs are going to increase, but the dipole-dipole and the hydrogen bond is going to decrease. So although one force is getting stronger, 2 of them are getting weaker, which is why it goes down. Okay, then we reach this turning point right here. We reach this turning point right around 4 to 5 carbons, and the reason that happens is the molecule really isn't polar anymore. As soon as it's not polar, there really isn't a dipole-dipole or a hydrogen bond anymore. So it's really basically just that LDF. Maybe a really weak hydrogen bond and dipole-dipole, but for the most part just LDF, which is why it then goes back to following that same pattern that the others follow, because it has more electrons, okay? It is higher though than alkynes, alkanes, and alkenes, and the reason it's higher is it has those additional intermolecular forces. Okay, so I threw in that little description for you. So you can just pause that as it ends. You can copy down that little bit of information